Example 4 will show us what happens when we end up with imaginary roots. So again, I'm going to skip ahead until step 3. With the exception of step 1, I just want to make sure you know that if they don't write in a number in front of the x, that coefficient is in fact 1. So a is 1, b is positive 1, c is positive 5. Here's step 2. And we're ready for step 3, which is to find the discriminant. So when I do this out, I get negative 19. That means we're looking at two imaginary roots. These are imaginary because if you try to take the square root of a negative 19, that's not going to work out so well for you. And if you forget about the existence of a square root of negative 1. So you can't put the square root of negative 19 into a calculator. But don't get too worried. We can still simplify everything that we have to simplify, including that green part. So I'm looking at step 2 again, and I'm saying x equals negative 1 plus or minus the square root of negative 19 all over 2. And now I'm back to this idea of the square root of a negative number. But there's a way to write that. Negative 1 plus or minus I is the square root of negative 1. So you guys like it when I write them straight. I times the square root of 19 is the same as the square root of negative 19. It's the exact same thing. So in other words, what I'm saying is that it is the case that the square root of negative 19 is equal to I times the square root of 19. And if you want more info on that, please ask. But that's how it works. Okay, so I was in the middle of saying that we're finishing this blue part. We have over 2. So our real answer here, we have 2 roots. Either x is negative 1 plus I square root 19. That cannot be simplified. All over 2. Or x is still negative 1, but it's minus I times the square root of 19 over 2. These are complex solutions, but they are totally valid. They are numbers that exist in the world. Not real numbers, but not fake either. They just have imaginary components. And there we have it.